Every human alive today shares a remarkable history that most people never realize. Not the history of kings, not the history of empires, the history of survival. There have been multiple points in Earth's past when our entire species came dangerously close to disappearing forever. At several moments, humanity may have been reduced to only a few thousand people, or perhaps even fewer. Every civilization, every language, every family tree, every DNA test, every ancestor you have, all survived because enough people endured events that easily could have erased our species from existence. Today we're following the story of every major catastrophe that nearly ended humanity and what ancient DNA, archaeology, geology, and genetics reveal about how we survived. Extinction doesn't require every individual to die at once. Instead, a species becomes vulnerable when its population falls so low that disease, famine, climate change, or simple bad luck can finish the job. Scientists refer to these events as population bottlenecks. A bottleneck occurs when only a small fraction of a population survives. Future generations descend from those survivors, reducing genetic diversity. One reason scientists can detect these events is because our DNA still carries evidence of them today. Our genomes preserve the fingerprints of ancient catastrophes. Modern Homo sapiens first appeared in Africa approximately 300,000 years ago. Life was harsh. Infant mortality was enormous. Predators were everywhere. Food supplies changed constantly. Humans lived as scattered bands of hunter-gatherers, often numbering only a few dozen individuals. Without agriculture or permanent settlements, every drought, failed hunt, or disease outbreak could threaten an entire group. Yet somehow these scattered populations expanded across Africa before eventually spreading throughout the world. Genetic research suggests that early Homo sapiens experienced one or more severe population bottlenecks long before leaving Africa. Some recent studies even propose that the breeding population may have dropped to around 1,000 individuals during one particularly severe period, though the exact numbers remain debated. Regardless of the precise estimate, researchers agree that our ancestors passed through periods of dramatically reduced population size. Every human alive today inherited DNA from these remarkably few survivors. One of Earth's largest known volcanic eruptions occurred at Lake Toba, in present-day Indonesia, roughly 74,000 years ago. The eruption expelled thousands of cubic kilometers of volcanic material into the atmosphere. Ash spread across much of Asia. Sunlight was reduced. Temperatures may have dropped significantly for years afterward. Some researchers once argued that this eruption nearly wiped out humanity. Others believe its effects have been overstated. Although debate continues, Toba remains one of the most dramatic natural disasters our species ever experienced, and may have intensified an already difficult period. For tens of thousands of years, humanity lived during the last ice age. Massive glaciers covered much of North America and northern Europe. Temperatures fluctuated dramatically. Entire ecosystems shifted. Animals disappeared from some regions and flourished in others. Human populations continually adapted by changing migration routes, hunting strategies, clothing, shelter, and social cooperation. Rather than one catastrophe, the Ice Age represented thousands of years of continual survival against changing environmental conditions. Around 60 to 70,000 years ago, a relatively small number of humans left Africa. Remarkably, nearly every person living outside Africa today descends from these migrants. This migration was itself another genetic bottleneck. Small founder populations spread into Europe, Asia, Australia, and eventually the Americas. Each migration reduced diversity slightly, while carrying forward the DNA of remarkably few individuals. As modern humans expanded across Eurasia, they encountered other human species. Neanderthals had occupied Europe and Western Asia for hundreds of thousands of years. Denisovans lived across parts of Asia. Rather than complete replacement, genetic evidence shows interbreeding occurred. Today, most people outside Africa still carry small amounts of Neanderthal DNA. Some populations also inherited Denisovan DNA, including genes that help Tibetans survive high-altitude environments. These encounters enriched our genetic history even as other human species eventually disappeared. Once agriculture began around 12,000 years ago, human populations grew rapidly, but so did disease. Living closely together with domesticated animals created entirely new opportunities for pathogens to evolve. Smallpox, measles, influenza, and tuberculosis. Countless epidemics shaped civilizations, entire regions lost substantial portions of their populations. Yet humanity continued adapting through immunity, genetics, medicine, and social organization. Until recently, much of this history remained invisible. Ancient DNA has transformed archaeology. Scientists can now recover genomes from individuals who lived thousands, even tens of thousands of years ago. These genomes reveal migrations, family relationships, interbreeding events, population crashes, and the recovery of human groups after disasters. Every year, ancient DNA reshapes our understanding of humanity's past. Why did our species survive when so many others disappeared? No single answer exists. Instead, our survival likely resulted from an extraordinary combination of adaptability, cooperation, language, innovation, migration, and resilience. Humans continually learned. We shared knowledge, we created tools, we cared for one another. Each generation inherited not only DNA, but culture. Together, those advantages allowed us to overcome challenges that might otherwise have ended our story. The story of humanity is not simply one of progress. It is a story of repeated survival. Our ancestors endured volcanic winters, changing climates, severe population bottlenecks, famine, disease, migration, and countless hardships that never entered the written record. Every family alive today is evidence that those survivors succeeded. The next time you look at your family tree, or even your own DNA, you are looking at the legacy of people who survived impossible odds. Their story is your story, and remarkably, it almost ended many times before any of us were ever born.